In this short video, we study section 4.3 nominal pthly discount rates. This is basically a sister section of section 4.2, where we studied nominal P's interest rates. So I upper P. So here what we do is D upper P. So first, let's introduce the notation. So D upper P. Okay, so again, this is nominal, which means pretty much the only use of this nominal discount rate is to get us the effective discount rate over 1 over P. So it's what we sometimes we call the pthly effective discount rate. So the nominal rate divided by the corresponding frequency. Then you get the effective discount rate over a unit period. So here the unit period is 1 over P years. So this is the unit period. Okay. From there, we can easily establish the equation because we know to get the pthly effective interest rate, discount rate, excuse me, we can also do this, right? D is the effective annual discount rate, right? So from here, we easily get a result. So this is straightforward, right? So let's put it in a box to say this is an important result we may need from time to time. So this tells us how you can convert from the effective discount rate to nominal discount rate. Of course, you can also go backwards, right? Okay. From there, what we can derive is what is 1 minus d. So divided by p on the right-hand side and use it, we get 1 minus d to the 1 over p equals 1 minus d upper p divided by p. Okay, so raise the power to p times. So we get 1 minus d equals 1 minus d upper p divided by p to the power of p. Okay, so of course, this works for any p, right? So I can keep writing. If I have discount rate, but at a different frequency, I should expect this, right? So that's the result put in the textbook, relationship between nominal discount rates, right? So of course, you can always pick either P or M to be 1. Then you go back to the special case we just discovered. Here we have some examples, but these are really, really elementary, right? You should be able to solve this example. Next, we study the relation between this. So let's call this P and the D upper M. So one is nominal interest rate. The other is nominal discount rate. And they have different frequency. One is P, the other is M. Let's take a look at their relation. So one thing we can do is to start with $1, and we look at the account value at 1. So if I'm on the left-hand side, if I use this is easy because IP divided by P is the effective pthly rate. So 1 plus this is the AV at 1 over P. And then I raise power P times, then I get the account value at time 1 by the end of 1 year. So I'm trying to do the same to using discount rate, okay? So what's everything? So it's here. All right, so let's say here's my scratch work. right? So 1 year discount factor equals 1 minus d, and 1 plus I equals 1 over v. That means it will be 1 minus d to negative 1, right? Okay, 1 minus d, I know from here, right? It will be 1 minus d upper m divided by m to the power of m. Then I need to times by negative 1, so it's negative m. So we easily derive this relation between I upper p and the d upper m. So that's the relation between nominal interest and the nominal discount, right? So it's summarized in this box. It's pretty much, we play with one thing that is over 1 year. So how are you going to calculate either the present value or the accumulated value at the end of 1 year by using different things? So that's the analysis. Once you know, everything should be in your mind for a long time. Let's do one example. Okay, let's do one example. 4.10. Determine the discount rate convertible monthly. So we want to know this, right? This is nominal rate, discount rate, convertible monthly, right? Monthly means P is 12. This should corresponds to, which means they are equivalent to an interest rate of 4% convertible quarterly. So I know I upper 4 is 4%. Well, then you just put everything in. 4% divided by 4 to the fourth. So it's 1.01 to the fourth equals 1 minus d upper 12 divided by 12 to negative 12. Right? So take the reciprocal of it. So it's negative 4 over 12. Then I remove the power, okay? And then obviously this will be 12 times 1 minus 1.01 to negative 1 over 3, right? Finally, it's time to get your calculator. It's slightly less than 4%. It's about 3.9735%. Okay. There's one more question. 2 examples. 4.11 asks you to calculate the accumulated value at time 10 years of payment of 1,000 at 5. So we have $1,000. We want to know the accumulated value at time 10 years. We know that discount is 5%, convertible every other month. So every other month, that means the compounding frequency is 6, right? We don't do monthly compounding, right? It's every other month. So every 2 months, you do it once, right? So there are 12 months in a year. So the frequency is actually 6. So which means what we know of the discount rate is D upper 6. Then, so first of all, you need to get D, right? Once you get D, you can, you can apply this if you want, or you directly get the discount factor, because that's what matters, because we know the accumulated value is 1 minus D to the negative distance. So in between, we have 5 years. So this is what this here, not this 5, okay? So that's the distance. So you simply need D, right? D is very easy to calculate using one of the formulas. The last one, we want to calculate the present value at time 0 of a payment of $250 at time 10 years. So we want to discount back by 10 years. The nominal rate of discount is 12 a year, convertibly biannually. So So again, those are rather straightforward as long as you get the notation correct. So from here, you can easily get D, right? D is nothing but 1 minus D upper 2 divided by 2, take square. So you get D, which is about 11.64%. Okay. What I need present value of $250 times by this 1 minus D is V, right? And the 250 is paid at 10, so I need to discount back by 10 years. Then it gives the result, right? By the way, a textbook also provides a slightly different, but it's pretty much the same. So what you do is you directly do the discounting, right? You don't need to always convert because we are in the world of compounding. So what we have is this. So what I just write down, 1 minus D upper 2 over 2, this is for 6 months, right? And we want to, this is pretty much the discount for 6 months. Now we want 10 years, okay? 10 years is nothing but 26 months, right? 10 years, there are 2 6 months a year, right? So if you want to discount by 10 years, you discount by 26 months, right? So this is probably easier comparing to the previous one, right? Previously, you always convert to 1 year, and then you do it for 10 years. Now we can directly see the number of years. So here's right, divided by the compounding frequency. So P is 2, so you get 20. So that's probably easier. Let me conclude here, and of course we will continue in the next video for 4.4.